Hello and welcome back to video number 2 of this playlist in which I'll be dealing with bunch of data analytics project. The first project that I did was on some IPL dataset. I hope you enjoyed that project. If you have not seen that project, if you have not watched that project so far, I suggest that you do so. It's a very interesting project. Now, this particular project today, dataset that I've chosen is a Amazon dataset. I have not done this project before, so I don't know what the dataset is all about. I mean, I have seen the dataset before, but not the project itself. I have not done the project, so I'll be shooting in the dark and learning as we go through this project. So uh, this particular project I've chosen because it is one of the most common project, and this e-commerce companies, they analyze their data set all the times, and I thought it would be a good idea to actually take some project that is quite different from the you know previous project that we have done, that is on some spot. So we'll be I'll be sharing you some of the slides just in a moment, where we'll see the description of the project. What are the steps that we'll be choosing for analyzing this particular data set, and then we'll try to code it out. All the slides, Jupyter notebook file and the dataset itself, it will be available to you. I'll leave the link in the description. You can go through that and just access the file yourself. But I suggest that you code along with me. That is, perhaps keep your YouTube window on one side of the screen, and the other side you can code along, or maybe you can choose some other device if you want to. That is on you. With that in mind, let us get started and see what the project is all about. Let me share the screen with you. Okay then, so this is Amazon sales project. This is what we'll be doing, and it's a looking at the dataset, I thought it's going to be quite interesting project. Let us see what we'll be doing. So first thing is, obviously we'll have a walkthrough of the dataset, what the dataset is trying to tell us, and what are the columns there. What are the approach that we can take to take this project, and then we'll have we'll try to understand the hierarchy of the dataset, that is again some insights of the dataset, and then we'll do some pre-processing. If you want to change the data types of some column, handle some missing values, we will do that in data pre-processing. And lastly, we'll perform some exploratory data analysis, both with and without visualization. So this is the overview of entire project, and these are the column details. That is, in a moment we'll be seeing the data set itself, but these are the columns details that will have. Obviously the PDF will be available, the slides will be available to you, but I suggest that if you're coding along, I recommend that you take a maybe screenshot of this column for the time being, so that you can understand when you are coding it out and dealing with actual data set. You can refer to these columns and try to have an idea what each column is representing. So product ID, I don't think I have to explain that. What is the name of the product, then the category of the product, discounted price, actual price, percentage of the discount. So everything is written here. Just keep a eye on what are the what are the details here for each and every column. Now the task here is very simple. That is, any data set that we have to make sure that it is clean. So this is what we'll be doing. That is, we'll be cleaning the data set first of all, and then we'll be preparing the data to ensure that it is consistent and it doesn't have any sort of accuracy problem, or some missing values are there, or some different data types are there. So we'll have to fix that. Then we'll summarize the data using some descriptive statistics on the maybe amount of sales in a year or in a quarter, things like that. Maybe try to visualize some of the findings using some charts and graph. This is what we're doing. And then we'll have certain outlier, something that is those are the data points that are not conforming to the trend of the other data points. Now then we'll maybe divide the data into certain groups. We'll see that when we go there, and then summarize our findings. So now this is again based on the the look of the dataset that I had, the glance of dataset, and I obviously created a map and you know an idea of how I'll be taking this particular project. So this is how I have created and noted down these bullet points. Now objective here is all this because we'll be exploring all the categories of the data set, how the prices have varied over a period of time, what are the ratings of the ratings of that product by the customer, and then maybe some of the factor that can influence other customer behavior, maybe decrease in the price, or maybe things like the if the product is new or not, maybe some things like that. Then we'll try to understand some of the patterns and trend of the top selling product, and maybe uncover some insights there. Then we'll obviously go to the some recommendation to improve the sales of the products, sales and outreach and effectiveness of the product, and then hopefully we'll have a deeper understanding of the steps that we'll be taking based on our analysis. All right, so let us talk about the libraries that we'll be using. And again, I try to keep things simple because there are just n number of libraries that you can use, n number of ways of achieving this project. But I think that most of the tasks, and majority of the people who need all these types of project run through, they find it quite easy to use if you they find it quite easy if we use just 4 libraries, and which are, in my opinion, the bedrock of data analytics in Python, that is Pandas, NumPy, Matplotlib, and Seaborn. So Pandas, again, if you do not know, we'll be using Pandas for data manipulation and analysis, NumPy for numerical operations and calculations, Matplotlib for some sort of basic visualization, and Seaborn for enhanced visualization. And just it basically enables to have that one-liner simple plots. And obviously we'll be using Seaborn along with Matplotlib if you want to make some changes. Now I'll be doing this project in the Jupyter notebook. You can feel free to use any other IDE, Google Colab, Spider, or whatever you can think of, but I'll be following Jupyter notebook here. All right, with that in mind, let us get started and jump to Jupyter notebook and see what are the things we have in our dataset. Okay, so there we go. I am here in my Jupyter notebook, and right away I'll be going to downloads because this is where I have my dataset with me, that is amazon.csv. Now you can store this dataset wherever you want, and you can run your notebook wherever you want, but I am doing this over here, that is in my downloads folder. Now here in this, I'm going to create a notebook that is in the same location where I'm having this file amazon.csv. In the same location, I have created this Jupyter notebook. Let me just name this as maybe Amazon project. Okay, so if right away the first thing that you have to do is import all the relevant libraries. So I'll do that. I'll be starting with importing numpy np, import pandas as pd, import matplotlib.pyplot as plt, import Seaborn as SNS. So these are the 4 libraries that I'll be using mostly. Let me use Pandas to read the datasets, and right away I'm going to assign this to df and say pd dot read underscore csv, and then you have amazon dot csv df dot head is the dataset that I have. Now you can see that this is the same dataset that I talked about in the slides. That is, product ID, product name. So you can see all the products name are here. Then the category, what the category is all about. Then the discounted price, what is the actual price, how many discount that we are giving. Then the rating, then rating count, what the product is all about. Maybe some user ID who has ordered it, what is the review ID, what is the review that he has given, review title, and then content. So a bunch of things here. Then image file, product link, everything is given here. So you can see that this is amazon.in. So I was not knowing that, but it is from Amazon India's dataset only. Now the purpose of a sneak peek is to get a quick review of a data and identify if there are any potential problems of areas of interest. But let us see some of the column names. So df dot columns here is going to give me all these columns names. So well, great. So just confirm this, that whether it is satisfying the list that we had in the slides, right? So you have this df, and if I just get the info from this, just to understand that there are 1465 rows, and thankfully there are no null values. So that's a good news. We don't have to worry about the null values here. And the number of rows are 16. So 16 columns and 1465 rows. Okay, so few observations here, that there are few there are almost no, okay, there is a missing value here in rating count apparently. Let me check that just to confirm if you have any other missing values. I'll say df dot is null and dot sum as this, and this will tell me that how many missing values are there in this. So just 2 missing rows, and that is completely fine. We can definitely handle that. But there are few more things to note, that all of them, the data type here, they are object, and object means all the columns, they are in actually string where they should not be. For example, the discounted price here, it is it is in string. Actual price, it is in string. So let me grab one of it. I'll say that df dot discounted price. You will know that this is having this rupee sign, and that is the perhaps the reason that I'm having this. Similarly, you can see that there's a comma here as well. So what I have to do is I have to fix this. First, I'll remove this rupee sign, and I'll also remove this comma as well. So let me do that. I'll say df discounted price dot str dot replace, and you replace the rupee sign. Now I do not have rupee sign in my keyboard, so I'll just copy this from this rupee sign. I basically want to replace it with nothing, and similarly I want to replace my comma with nothing again. And if you do that and run this, you will see that the resulting series, as we call it, it is not having this rupee sign and commas. Let us assign this back to, by the way, there was one more change that we have to make. The data type here, you can see it is still object. So if it is an object, quite clearly we have you know we have to change the data type. So I'll say dot as type. So dot as type, and then I'll say uh, float 64, right? And you can see that I've converted everything to floating number. You can see data type is floating number. You can assign this back to the discounted price, and thereby your column discounted price has been taken care of. If you try to run this info here one more time, you can see that this discounted price is now having this floating number. Great. But apparently the problem is not just of discounted price, it is also of actual price, and the problems are same. So let me just verify this. Yeah, we have commas and rupee sign as well. So what I'm going to do is just take this as it is, and just instead of discounted price, I'll just put actual price here, and thereby the same thing will apply in this case. There we go. Okay, and I'll put these two things in the same cell just to save some space. There we go. Okay, so two things are taken care of. Are there any other numerical column? And we are getting this error because we have already changed the column itself. So what I'm going to do here is just go here and run all the cells. There we go. Fine. Okay, so now this is about discounted price and actual price. How about discount percentage? Let us check that as well. So you have df discount percentage. You can see you have bunch of percentages here. Again, I'll fix that using the same idea, that is, instead of R sign, because I do not expect a R sign here, I'll put percentage sign, and I have to not worry about the commas in this case because there are no commas. So I'll just remove this entire thing, and this is percentage. I'll do one more thing. After converting this into floating number, I'll convert this into decimal, that is divide everything by 100. Yeah, so if you do that and check your df discount again, you will see, okay, I got an error again. Yeah, because it is not actual price, it is discounted percentage. That was the issue. Let us fix that. Discount percentage, and there you can see now I have everything in this decimal. Great. What are other things? So this has been taken care of, a discount percentage, and then we have the rating column here. Yeah, so rating column, let us check that. Rating column, it is object again, so that's not a good news. Let me check that. So df rating, you can see it is this decimal, and data type is object. Not good. If you take the value count of this, or maybe try to change it, because I know for a fact that there has to be some problem here. So if I try to change this into floating 64, yeah, if I do that, I'll get this error, and this error, it says that I cannot convert string to floating number if I find this kind of pipe. So there is a pipe in my rating column, and if you want to verify this, I'll say that df rating dot value counts is this. You can see that 4.1 is there, 244 is there, then you see this pipe operator. This is the problem. So let us see what this pipe operator is all about. So I'll say df dot query and get me the value, the column name rating, where this is equal to a pipe. So I'll put double quote and pipe here. Run that. You can see this is the product that I have, which is having this rating as pipe. You can see this pipe over here, which is quite strange. Now, we have to do something about it. So this product that we have, Eureka, Forbes, and what. So what I'm going to do is actually look for this product online on Amazon itself. That is, take this product ID and go to amazon.in and maybe search for this. Hopefully, is this the same product? Okay, not this one. There we go. So it is Eureka, Forbes, car, vacuum cleaner. Yes, it is the same product. Yeah. So we have this product and the rating, which happens to be in some decimal number. I'm looking for that actually. I do not see any rating here. Yeah, there we go. So it's 3.9. Okay, so 3.9, and obviously it's an old data set, so you cannot, the rating here, here we had 992, but over a period of time that this has grown to 2181. But the point is we have this customer rating is 3.9, and I'll just consider that as it is, right? So let us go to now our usual stuff. That is, I have to replace this pipe operator with something else. That is, I'll say df rating, then dot str dot replace, then some pipe operator, comma, and we'll say 3.9, and dot as type as float 64. Run that. There you go. Great. So you can see that we have replaced it apparently, but let me see the ratings here one more time. I'll assign this back to ratings. And if you do that, so we have changed the type here, right away, because it was doable now since we have replaced this pipe with 3.9. So I've done that, and I'm going to assign this back to rating now. So run that. There we go. Now just check the df one more time. If you see the df, so this 3 have been taken care of. That is all the ratings. How about rating count? Let us do that as well. So I'll just simply take this and come down here and say that rating count, and here as well rating count. So basically I've changed the type of this as well. Okay, so there should not be any pipe operator. I'm sorry. I'll have to remove this. Run that. Now this will again give me an error, and the error says could not convert floating. Okay, so we have to replace, there's a comma here as well. Okay, quite a task. So we have to take care of the comma, and taking care of comma is something that I have done over here. So I'll just take this as it is, come down, and put this over here. Run that. There you go. Now if you check this df again, if you check this one more time, let me run this, then check the rating count. Now it is floating number as well. Great. By the way, if you want to take this into integer, feel free to do so as well. I'm just taking floating number for just to because integer can be taken as floating number itself. So I just feel comfortable using floating number, so that I don't have to worry about the data type later on when we are going to the statistics. Okay, so speaking of statistics, let us go and do that right away. I'm going to put some heading right away. I'll say that this is descriptive statistics. Now, descriptive statistics, they are basically nothing but collection of quantitative measure that summarize the described characteristic of a data set. And what I mean by that is basically if I say df dot describe and run that, you'll say that I have this describe data frame. So that basically is telling me that what is the mean discounted price, what is the mean actual price, if that matters, but what is the mean discount percentage that we are giving on our website, that is on Amazon. And then we have what is the mean rating. This can be quite interesting. Then the rating count, how many people have rated. But right away, all the columns, the data type was object here, so I converted some column data type to 4, and there are 4 numeric as per Python coding or descriptive you know not 4 column, rather 5 columns that basically are numeric, so that is why we have taken this. Now there are few more things that we have to do, is taking care of this null value or missing value. You should remember that you have this rating count where we have this null value. Now the way you are going to deal with this is very simple. So this is about there are 2 rows which is having this null value. So I want to just have an idea that what this null values, which product ID do where we have this null value. So right away, let me do that. I'll say handling missing values. And if you want to take in a way the pipe operator that we had, it was also a null value. Okay, so but let us take that. So I'll say that df rating count, because this is where we had the null value. I'll say is null, and then I'll say that this is head. No use of head here because there are just 2 rows. So there we go. We have this 2 products where we have the rating count as NaN. Okay. Now what we can do is we can either look for the product just like what we have done in the Eureka product, the one that we saw earlier. Now that is the usual way to deal with this. So let me see this, if this can work. So run that, and this is the product that we have. Is I don't see anything, it is all sponsored, unfortunately. Amazon brand 65 watt. Okay, let me just check one more time. So this is no, I don't say anything. Let me try one more time. Maybe I'll query the product itself if it is possible. Yeah, no, this is again a sponsored product. Not looking for this one. All of them are sponsored so far. I don't think we have that. Okay, no issues. So we cannot do it like this. Now since it is one product, either what you can do at this point is either you delete this or you just take the median of the rating count. So what I'm going to do basically is I'll say that I have certain median of the rating count, and median is going to be this. This is the median that I have. Now I'm going to fill the rating count with this number. So I'm taking the median and just, and again, median, if you're not aware, just find out. But basically it is about, separating your data points into two halves, and then you're taking the middle point. So that is the meaning. But let me say that df then rating count df rating count dot fill na with what you're going to fill with this value and put that over here. Great. Now assign this back to the rating count and check the is null again one more time. So if you just go back and copy this code from this one. So just take this and come down and run this one more time. You can see that I have now taken care of the rating count. Basically, I have replaced the null values with the median of the rating count. Okay, so this is the milestone 1 in my opinion, because we have cleaned the data set, we have taken care of all the null values, we have taken care of all the data types more or less. There are certain more data types that I have not gone into. For example, the user ID, which was again it should be depending on what it is. If I just look at the data set here, it is okay, it is alphabet, so it is a string rightfully. So all of them apparently they are strings only. Reviewer ID, reviewer title, everything, it has to be strings. So we have cleaned our data set, we have taken care of the missing value, we have taken care of the data type of the column. Now let us go to one more thing, that is duplicates, right? So we'll take care of the duplicates, and just to make sure that there are no duplicate rows and rows in my duplicate rows in my data set. So we'll do that. So duplicates is this, and I'll say df dot duplicated, and if you run that as it is, it will be a bunch of true and false statement, but I'm looking for just true. The way you can do this is just assign this equal to true, and look for the data frame, look for the rows which are having duplicates. So if you run that, you are basically going to get nothing, because there are no duplicates here. Okay, so no duplicates, that's good news for us. Okay, so this is duplicates and no duplicates found, so you can take that. Now let us go into some of the visualization. Let us try to understand. So we have bunch of columns here. Let me try to understand that what is the price and rating graph maybe. Okay, so I'll see this is price versus actual price, in fact actual price versus rating. And what you're going to do is plot a scatter plot. So I'll say plt.scatter, or you can use sns.scatterplot as well if you want to do that. I'll maybe use that only. So I'll say sns.scatter plot. On x-axis, I want the actual price, that is the column name. Y is equal to again the column name, that is rating, and data is df, and you run that, you'll find this very nice looking scatter plot. So apparently observations are quite clear that lower I mean, that is if there's anything that you have to take away home, is you have to understand that perhaps there are more cells of the lower priced product than there are of higher price. You can see at most as you go beyond 40,000, and those I believe some appliances or mobile phones or something like that, if you go beyond that range of about 35,000 or 40,000, your products, the sales itself, they are going to go down. Okay, now since this is the observation, maybe it is going to be a good idea to have a distribution of actual price. So I'll say distribution of actual price. The way you're going to do this, I'll say plt dot, and again, in fact, you can use histogram, sns dot histogram, or you can say plt dot hist, and then use the matplotlib. And I'll just take this everything from here and make some changes. That is why I cannot put y there, because it's a histogram. And you run that, there we go. This is the histogram that I'm getting. Okay, great. Let me put some bin size. So bins is equal to some, maybe a range of 10,000 would be better. Not really, because we do not have that x-axis that is going to be useful for us. Maybe if I put bin size of 1,000, yeah, now it is more or less okay, not perfect, but still fine. But the bins here, you can right away you can see that lesser product, they are having much more cells. You can say count is going upward. Maybe I'll try to put some limit here, try to understand that how does this look like. So I'll say plt dot x limit, it is going from 0 to maybe 1,000. So I'm just taking the prices which are going from 0 to 1,000. Right away you can say it's a huge upshoot there. Maybe in fact instead of 1,000 I'll put 5,000. Yeah, much better. So you can see that the prices which is going from 0 to 5,000, these are the distribution. This is the histogram of that that histogram. All right, okay, great. Now let us try to take a step forward and try to go into the grouping and aggregation. So I'll say grouping and aggregation. So I'll say that maybe I would like to calculate the ratings per category. Now if you see the df dot category here, there are a bunch of categories, isn't it? So I'll maybe first try to understand what are the categories there. So these are going to give me the value counts, is going to give me the number of category, and you can see that compared accessories 2 to 3, electronics with variable technology, maybe basically the smartwatch, it is having 76. Then you have the smartphone and basic mobiles, it is having 68, and so on and so forth. So this is actually how it works, but maybe try to get the mean cells of each product category. So I'll say that df dot group by, and I want to do a group by on category, and then you have rating dot main. So what I'm doing basically is for each of the category, what is the mean rating that I'm getting, and you can see that car, motorbike, it is having a rating of 3.8. Computer accessories, it is 4.5. Then computer accessories for basically this USB to USB adapter, this 4.5, and so bunch of things here. Okay, now let us try to calculate some summary statistics for each of the groups. I'll start with some I'll take multiple things together because that will be much more time saver. So I'll say calculate summary statistics for groups. So I'll say first one is mean rating by category. I'll say that df dot group by and pass in category, then rating dot mean, and I'll just print that. And why I'm printing this, because I want multiple values here. So this is the first thing. Then I have df dot group by, then I'll say I want if I just have a look at my df, you will see that I have taken category. Now I also have review content is also there. So maybe I want to get for review content, what is the median rating by review content basically, or maybe standard deviation of actual price by the product name. Okay, maybe that can be a good idea. So let us try to do that. So I'll say that this is group by, and then I'll say that this is product name, product underscore name, then actual price dot standard deviation, and I'll print this one more time. There you go. Great. So this is group by. First one, I think we have already seen this 3.1, 4.5 and all. So I'll just go back and delete this because it is not, this will duplication of information. So I'll remove that. And I can see that I have getting all these values, and we also have this value, well, not really informative in my opinion. So you can see that it is having 4.5 for this office product and all. So there's a bunch of things here. Okay, so this is group by. Let me do one more thing, that is try to hopefully maybe try to do some more visualization here. Okay, so let us see the data set that I have here. Maybe what is the average rating for every product category. Okay, we have already done that because this is what we are getting when you have saying that average category. Maybe I'll try to get top rating count products by each category. That is, and I'll put the question here. So top rating count products by category. So I'll say that df dot group by, then you'll have to mention the category, that is the column on which you'll be doing the group by, and then you will be applying lambda, and that lambda will I'm saying that I want the top 10. So I'll say x is x dot n largest, and I want 10, and I want to get the rating count basically, rating count. And if you run that, you will see that this is what I'm getting. I'll do one more thing. I'll just drop the category here because I don't want that. Reset. Sorry, I'll drop the index basically. I'll say reset index, and then I'll drop it all together. There you go. So you have product ID, then product name, whatever the product name is. Then you have the rating count that is starting this particular product. It is having, whatever this is, 1011, 1118. and then 4426. So these are the product counts that we have. Now what you can do is maybe you can try to get the uh, you can do a sort if you want to using this, but these are the top 10 rating counts. Yeah. Okay, assign this to some variable. I'll say this is top reviewed per category is equal to this, right? And then you can print it if you want to. Great. Yeah. All right then. So we have all these values. Now let me go to the next question. Maybe try to understand. By the way, few things here. The output actually highlights products likely to be popular within their category if it is not clear, based on based on high review counts, suggesting that customer interest and engagement. So review counts, it ranged from whatever the range is. Yeah. And it is, I think you can see that uh, basically for every category we have that review count. That is what we have done. Okay, so if you're wondering that why it is not 10, you have to understand that we are doing for every category, and that is why we have all this, just many rows here. That is 820 rows basically. Okay, now what is the distribution of discounted price versus actual price is also something that you have to understand, because people, especially this e-commerce company, they tend to give much more discount, something called as predatory pricing, to eliminate the competition. So let us see what is the discounted price that we are getting versus actual price. So I'll say discounted price versus actual price, and I'll use this to create the histogram. I'll say that df dot discounted price dot histogram, and you have this, run that, and this is the histogram that we have. Okay, and what about the df dot actual price dot histogram is this. Oh, we have used the same cell, I'm sorry. We have this, and next cell is this. So you can see that there's not much difference. The difference between the highest number and lowest number, it is not there. But discounted prices, they generally tend to be lower than the actual price. If you take the median of that, I'll say that the the discounted price, the median of discounted price, let us check that. df discounted price dot median, it is about $800, and the actual price, the median of that, it is around 1650. So you can see that there's a huge difference. Okay, and this discount percentage, if I can get that, let us try to create. Do we have discount percent? I think we have, right? So I'll say that df then discount percentage is this, And if I say try to plot this, you can see that it is having about 60% and 80% discount. Okay, so this is quite high in my opinion, right? So uh, now let us try to understand how does the discount percentage that we had, they vary across the category, because this is, we have taken this entire thing. So what is discount percentage if we take them, for each of the categories? So I'll say that, average discount percentage per category. I'll say that df dot group by and pass in category, and then maybe we'll say that I want discount percentage dot mean. Yeah, it is category. Be careful of the spelling mistakes. There we go. So this is the discounted category. Now if you just sort this, okay, so you can see that it is in now sorted. Now if you just do uh, ascending, if it's not correct, then, and if you do that, you'll have in ascending order. Let me get the top 10, and there we go. So you have top 10 categories. You can see that the uh, the phone and all that, whatever this is the highest rated category, highest discounted discount percentage category. Then cable connection protector, then earpads, adapter. So most of the things, they are computer and accessories and electronics only, and that is confirming to the general trend that we have seen over the years. Okay, so it can go to as much as 90%, and that is quite a uh, quite a high name. Now let me try to answer some more questions, maybe starting with popular. What is the most popular product? So I'll say df dot product id and not name, and I'll say dot value counts, and so I'll say that, there we go, these are the products. In fact, there can be different, same product name with different IDs as well. So that is have kind of changed it, because it can be misleading to just go with the product ID, but we have this. And here I will do a sort again, sort values, basically the same thing that we did here, right? So I'll just copy this entire thing, since we are looking for the top 10 values. There you go. So this particular product, whatever this is, Firebolt Ninja Pro, so this is the perhaps the most popular product out there. Okay, so let me now answer some questions like what are the most popular product reviews maybe, and for that I will kind of tone down a little bit and also import a library that is called as text blob library. So if you have not installed, let me let me make sure that I have at my end. So this is text blob import text blob. I done that. Yeah, it is working for me. So I do have installed. Now if you do not have that, you can, what you can do basically is just install it, and for that you will have to say exclamation mark pip install dash u and text blob. Okay, so just run this without hash. Obviously I already have installed, so that is I'm not running that. But let us select the columns in question first of all, because in df you have bunch of columns, not all of them are important for us. So the columns that I'm going to be needing is this 3 columns. One is product id, then another one is review content, and the user id. So these are the columns that we are looking for in order to get the most popular product reviews. Let us do that. So I'll say that df, and I want to get product id, and I want user id, and I want review content. Okay, so these are the you know the columns that we'll be dealing with basically. Now let us try to create one more column here, that is using this review content. I want to understand that how much is how much are the some words are being getting repeated. That is, I'll say or basically understand the sentiment score for each of the review. So I'll say basically that review content and dot apply. I'll say lambda. Then I'm saying that any text that I have, take that text and make it pass through text blob library. Once you do that, try to get the sentiment out of it and the polarity. If you run that, you will have bunch of numbers here which are nothing but the sentiment of each and every product. I'm going to assign this to some variable, that is some column. I'll say this is df sentiment, and then you have this. Run that. There we go. Now I'm going to take this sentiment and do a sort. So I'll say df dot sort values, and I'm going to say by equal to the sentiment, that is this. You have to remove this df here and run that. So if you see this data set that we have, you can see that I'm having starting from minus. So okay, so this is descending. I'm not looking for that. I want the ascending. So I'll have to say sorry, I want the greater number first, then the lower number. So ascending is false. Run that, and then you can have a look at the products which are having best sentiment, and then some other products are there as well. So I don't know, Ketan, CP Plus, these are the cameras. So bunch of things here. Okay, now this is the sentiment of every product. You can get the top 10 by just putting the head and 10 there. I'm leaving it on you, and then you can have just the product name and product ID, product name, and then the sentiment. Okay, so maybe I'll try doing that. I'll say this is product name comma sentiment. Now we run that, you can see that for every product what is the sentiment score that we have is there. So perhaps people think more highly of this product over here than the product that is at the bottom. Okay, so many things we have covered, and I hope that this is it. Lastly, let me think of any other thing that we can uh, maybe find, maybe try to understand that what is the correlation between discounted price and rating. Because if your product is having negative ratings, people are going to have uh, you know they are going to offer you more discount basically. So if I try to do that, I'll say again, what is correlation between discounted price and rating. Let's try that. So I'll say df dot discounted price dot correlation df rating. Okay, just 12%. It's a weak correlation, weak positive correlation. This means that the product with higher discounted price tend to have a slightly higher ratings, but the relationship is not very strong. So because there's just 12.12 correlation there. Maybe last one question. Okay, so I'll say that what are the maybe uh, top 5 categories based with highest rating, right? So this is the question. Top 5 categories based with highest ratings. So I'll say that df dot group by and category rating dot mean. Run that. Yeah, okay, we have done this already. Okay, no issues. So I'll say maybe reset index. There you go. So this is giving me a better idea of this. Now you can sort this value again and try to get the which are the top 5 categories. So I'll say dot sort underscore values, and here you'll have to mention that which column that you're referring to, because we have already reset the index. So I'll have to say by equal to rating, because this is a data frame, right? So sort values, then you'll have to mention the column name, and there I'll say ascending equal to false. Run that, and this is ascending is equal to false. So these are the categories. Again, no surprises here really, but these are the categories that we have, which is the having highest ratings. Okay, now so this is the project in my opinion, and this is enough that whatever we have covered. The primary goal of this project was to give you an idea of how to tackle this Amazon sales dataset and insights based on that. Now there are many more things that we have not covered in my opinion. That is things like what are the correlations, what we have not gone into the prediction. For example, based on this dataset, if a new sales goes through, what is the maybe prediction of the ratings, for example. So all this predictive modeling is something that we have not done, because that again it comes under machine learning. The idea was here to just analyze the project at the basic level, and we have just used the 4 libraries, that is NumPy, Pandas, Matplotlib, and Seaborn. Obviously data analytics goes much more beyond that, but I will keep that for a later project, because I mean this is already just too big of a video, too lengthy a video, and those kind of projects it takes quite a while. That project will be around, I mean at the least it will be 2-hour video. So if you're interested in that, just let me know in the comment section. I'll be happy to create a video in that. With that, it's a wrap for this particular project. I'll see you in the next one. Thank you and goodbye.